we're going to start our problem with a quarter circle. Then, using the bottom radius of this quarter circle, we will construct and inscribe a circular sector inside this quarter circle so that the radius of the circular sector is identical to the radius of our quarter circle, and we will pull it up until it meets the arc of the quarter circle, as you can see on the sketch. Now we will use the remaining upper right part of our quarter circle to construct a full circle with the area of 1. And the question is, can we somehow calculate the area of red circular sector? So if you guys want to try out this interesting problem, you can pause the video right now, as always, and then come back and check the solution. Alright, so let's solve this problem. So first, I'm going to isolate the value of the area of this small circle, and we're going to keep this value for later. Then I'm going to label the center of our quarter circle as A, and I will label the radius of this quarter circle as capital R. But now, let's pay attention to the radius of our circular sector, and we can notice that this radius is exactly the same as the radius of our quarter circle. And let's label the center of our circular sector as B. Finally, let's label the center of our inscribed circle as C, and let's say that the radius of this circle is small r. Now, first, let's have a look at the touching point between our circular sector and our full circle. And let's rotate the radius of our circular sector and our full circle to this point. You can notice that we have formed a straight line BC. But how do we know that this is a straight line? Well, we're going to use a circular theorem which states that if two circles touch each other, externally or internally, then their point of contact lies on a straight line joining their centers. And as you can see, this is exactly our case. Now, let's have a look at this horizontal radius of our small circle. And let's slide it down to the radius of our big quarter circle, and we can label this new intersection point as D. Now you can see that we have formed this really nice right-angled triangle BDC. And we already know something about this triangle. We know that the length of the hypotenuse BC consists out of capital R and small r. But we also know that the leg BD is nothing but the difference between the radius of our big quarter circle and the radius of our small circle. So, let's try to use the Pythagorean Theorem to find out the length DC. So, the leg DC squared equals to the hypotenuse BC squared minus the leg BD squared, and we can substitute our values from the sketch. Now we can expand by using the square of binomial, and then we can get rid of the brackets by changing the signs inside the brackets. Finally, we're going to simplify by cancelling capital R squared and small r squared, and we will get that DC squared equals 4 times capital R times small r, and we're going to leave this value as it is. Now, let's have a look at our sketch once again, but this time let's dim out our circular sector and let's just focus on our quarter circle and our full circle. And let's mark their point of contact. Now let's rotate the radius of our quarter circle and our full circle to this point of contact. And again we will form a straight line. How do we know this? Well, again, we will use the same theorem as we did a couple of minutes ago, but this time two circles will touch each other internally. Now, as you can see, this is exactly our case from the sketch. Why is this important? Well, because in this way we know that the length of the line AC is nothing but the difference between the radius of our quarter circle and the radius of our small circle. Now, let's go ahead and notice another right-angle triangle, DAC. And let's apply the Pythagorean theorem into this triangle as well. We can say that hypotenuse CA squared equals to the sum of the leg DA squared and the leg DC squared. Then you can notice that we already have the value of DC squared, so we're just going to implement this value, and for the other ones, we're just going to implement the values from the sketch, and we will get the following. Now, we can again expand the left side by using the square of binomial, then we can cancel small r squared, and after rearranging the terms, we will get the following. Then we can simplify our new equation by dividing with capital R. We can do this safely because we know that capital R cannot have the value of 0, and we will get that capital R equals 6 times small r. And now let's go back to our sketch, and remember, we're looking for the area of the circular sector, but we don't know the central angle of this sector, so let's try to find this angle first. We can do this by rotating the radius of our quarter circle up until the apex of our circular sector, and we will rotate the radius of our circular sector up until the same point. Now you can see that we have formed this really nice equilateral triangle. And of course, the property of an equilateral triangle is that all sides are equal, but all interior angles are equal and all of them are 60-degree angles. And this is important because this means that the angle at the point B must be 60-degree angle, and this is exactly the central angle of our circular sector. Now we can calculate the area. We can use the formula for the area of the circular sector, where theta is the central angle, and we can substitute the value of theta, but we can also substitute the value of 6 small r for capital R and get the following. Now we can do some simplifications and put the value of 6r to the square. Then we will simplify 6 and 36 and get that our red area equals 6 times pi small r squared. But what is the value of pi small r squared? Well, this is actually the value of the area of our small circle. And we already know that this circle has the area of 1, so we can just substitute this value and get that the area of our red circular sector is 6 squared units, and this is our solution. Well, I really hope you guys enjoyed this problem. If you did, do not hesitate to leave a like or subscribe to the channel for more content like this in the future. And if you found another way to solve this problem, please write it down in the comment section, and until next time, see you guys and take care.